In this video, I will show you how to make a cool planet, a cool procedural planet with simplex noise from DevDad and from DevDad's plugin and runtime mesh component. So first off, you need to create a new project. I'll make it blank, no starter content and maximum quality. I'll just call it procedural planet. After you created the project, you need to go to the project files. So to go to the project files, you could just create a new project, new folder. You can call that blueprints. Inside of it, you can just select it and show in Explorer. Okay, then you can go to the project here and you need to make a new folder. This folder is gonna be for the plugins. You need to call that plugins. After you did that, open the folder, go to the media file where I put the plugins you need to install them. It's gonna say you that, but just keep it. Then just drag and drop plugins inside the plugins folder of the project. Then you need to unzip it. You may have 7-zip or WinRAR. You just need to have an archive thing to unzip it. So I'm just gonna unzip it here. Gonna put the runtime mesh component, the simplex noise. Then you could just remove this. Now just need to close the project and reopen it. So after you opened it, it's gonna say probably new plugins available, but if it doesn't say that, you just can come here, edit plugins, not in the installed, but here in the project, and you need to enable the simplex noise one and the runtime mesh component one. The runtime mesh is from coders and simplex noise is from DevDad. I put the links for their GitHub repositories so you can check the plugins out. Okay, after you did that, just open the blueprints folder, make a new actor, new blueprint, and then new actor. You might call this procedural planet. Open it. Okay, I'm just gonna resize that. Okay. In components, you need to add a new component and add the runtime mesh component. Then you can come to the event graph and we can start coding. So you might want to remove those two, actor begin overlap and tick, and just let begin play. Okay, so here you should remove the event overlap and tick, and in the begin play just want to get you want to do two variables at first. two variables. Gonna call the first variable resolution. This is gonna be the resolution of the planet. But to make it public, and another variable is gonna be scale. It's not an integer because resolution is an integer and scale is a float. Want it to be public too. Okay, so in event begin play, you want to come here and create grid mesh because we activated the runtime mesh component, so we can do that. In width and height, we just put scale and number of subdivisions and the X and the Y. You just want to put resolution. Okay, after we did that, we want to make a new variable called vertices. It's a vector and it's an array. Here, before you create the grid mesh, you want to do a for loop. So this is gonna, because we're gonna first off make a cube, then transform it to a sphere by normalizing each vertex. So the cube has 6 faces. Well, actually 5, because it counts 0 as a loop body. We're gonna do that. Then we can make a variable called faces rotation. It's gonna be public again. It's not a vector 3 this time, it's a rotator. Okay, after we did that, we can come here, get faces, get the faces rotation, and do a get. We're gonna get the rotation for each face. We're gonna get the vertices, and we're gonna do for each loop, because now we're gonna rotate each vertex to make it look like it's like cubic. Then we can change it to a sphere. Here's the rotation. Here, just need to do rotate vector, and boom. That's all you have to do. Rotate vector, and you rotate it by the get. But before that, because if we just come here and we do an add, that won't do it, because it's all still gonna add if we change the face. So each time we change a face, we need to clear the vertices array. Just get it and array clear. I'm gonna move it so it's better. So here's what we have right now. We are looping in each face, then we're creating a grid with the scale and a resolution. We're clearing the vertices array, and we're gonna do for each loop of the grid vertices here. Then we're gonna add the rotated vertex by the rotation to the vertices array. Yeah, and we might do triangles. Yeah, we're gonna do variable called triangles. This is gonna keep track of the triangles that we have here, because we're technically gonna make a lot of 6 mesh sections. Then we're gonna for each mesh section we're gonna have, it's technically gonna be each face. So then after we did that, we can come here and runtime a mesh. Oh, before we even do that, we need to take the scale. Yep. Need to come here. Before we rotate it, we need to add a vector in the z-axis, because now we just have a flat plane. It's not cubic, because if you have just a flat plane, it's gonna give weird results. It's not gonna give a perfect cube. It's not even gonna give a cube. So we need to come here, make a vector. This is an Unreal Engine 4.21, by the way, I think. I'm gonna get the scale. I'm gonna move all of this down. Better. Gonna get the scale and divide it by 2. Then connect it to the Z. So we're gonna offset each face. Like we're gonna extrude each face on the Z axis. But since it's gonna be rotated after, it's gonna look like a cube. That's all I know. We can come here and do a reroute node. Reroute node. Come here, do in the runtime mesh, we can get that component, and we can just do create mesh section. Boom. That's all, and we can connect it. Now for the section integer, we just need to get the face index. Since I said earlier, each section is technically each face, so that. And we have the vertices. Before that, we can recalculate the tangents and normals for the faces. I mean, for the vertices and triangles. So we might do calculate tangents for mesh. That from the runtime mesh component category. Normals here, tangents here. Oh yeah, we need to have UVs, but we already have them here. I'll just bring the UVs. Oh, they're not the same. Okay, that's the runtime mesh. This is from runtime mesh. That's weird. Well, apparently it's not compatible, so we might use the small ones. Oh, did I use tangents instead? Maybe I did bigger. Sorry. These. Yep, I was wrong. I tried to connect it to the tangents, but it was actually the one above it. Wow, I'm so smart. Okay, so it's from the runtime mesh library. Then connect them. Normals to normals. Tangents to tangents. Then we have the vertices array here. The triangles array here. And here, in create mesh section, we have the vertices array. Connect it. Then triangles array. Connect it. That's technically all you have to do. Now we might from here. Maybe I'm gonna compact this to. I'm gonna collapse it to a function and call that function generate planet. I have the function here. Gonna here. The construction script. I'm gonna generate the planet. So each time we change. Oh wait, hold up. We need to do a branch. So we can put it so it generates when we change the variables or just be static. Promote to variable can change. It's gonna be bool, since it's a branch, during construct. Boom. Compile. And no, we're gonna put it to no for now, because it's gonna crash Unreal Engine 4, because resolution we have 0. At least we need to put it at 3 at least. Okay, and now we can bring it here. We might put the scale to maybe 5. We need to have 6. Oh wait, yeah, 6 array elements. The scale 5. Oh, that's true. We didn't put this to be public. So put the bool to be public. We can change it here. And boom. For now, we have just a little face. So this is one face of the cube, but it's correctly generated. I'm just gonna make it bigger for now. Gonna make it like 500. Better. Okay, so this is one face of the cube, but we're gonna make it a planet after. Okay, that's one face. Then we need to rotate that thing, which makes a second face. So each time we rotate this, it makes a new face. Oh wait, okay. Maybe we can't do 360. Maybe minus 19. Okay. Now we have those faces, but we still have the faces inside from those sides. Maybe within them. Okay, not in that direction. One there, so the other is minus. So you can come and copy the face rotations variable. So for the face 0, it's 0, 0, 0. The face 1, it's 0, 19, 0. Face 2, 0, 118, 0. And face 3, 0, minus 90, 0. 4 is 90, 0, 0. 5 is minus 90, 0, 0. Now we have a perfect cube. Okay, hope it's still recording. Yes, it is. Then we can just come in the generate planet function, and instead of connecting them like that, we just need to normalize them. So just normalize. Normalizing means that it's always gonna give a value between the length of the vector is probably gonna be always 1, which is gonna probably okay, it did work, but since it's always gonna be between 0 and 1, the length of the vector is always 1, then the shape is very small. So even if we change the scale, it won't change anything. Put the scale to 1, or to 0, it will not work. We're gonna put this scale to be not public now, and just leave it as 1. And we can make a new variable called radius, because now we use a sphere, so we can use the word radius. Do that. Then after we normalize the rotated vector, we can just multiply it by the radius, so it makes a smaller or bigger shape. I mean smaller or bigger sphere. And I still didn't put this radius variable to public. In any case, if you don't understand anything, I'll put a lot of screenshots in the comment section, so you could just copy from there. Here the radius, put it to 1. It's very small, so we don't see it, but maybe 100. At 100 it's fine, but as you can see, it has some weird normal bugs, because since each face it's like it's a face and they're not connected together, then the normals aren't properly calculated, but that bug can be fixed if we if we increase the resolution a bit. You see, if we increase the resolution a lot more, the bug isn't fixed, and the bug is fixed. So thank you for watching the first part of this tutorial. In the next part, we will be working on using the simplex noise and making multiple presets. So you can change the frequency, add more detail, change the octaves, the heights, and all that. So yeah, thanks for watching.